In this video, I'm going to show you how to find limits analytically. This is for pre-calculus. And at the time of this video, I haven't really had a chance to talk to you all about what a limit is. And really a limit is just what value does some function approach as it's getting, like what y value does it approach as it's getting to an x value close to at an x value. So you've seen this in graphs, and we haven't talked about it numerically yet, like in a table, but we're going to do it analytically today. And this is really just algebraically. We call it analytically because we're going to be breaking down the problem a little bit to kind of see what's going on here. So, think of this kind of along the lines of algebra. And when we get into calculus next year, we're going to be finding limits quite a bit. Like all through the year, really, but right away at the beginning. So this is kind of a good prep for you if you're going into calculus, if you're going into college algebra next year. Okay, we want to find the limit of this function, and we want to find it in 3 different places. And you can see those over here, okay? As it approaches 4, -1, and 2, and these are all separate, but let's get going. So if we just plug a 4 in here, we're going to have 4 squared minus 12 minus 4. And when we're doing analytically, we really take this wherever it's approaching x, and we're plugging that in. And this is going to be over 5. 4 squared is 16. Minus 12 is 4. Minus 4 is 0 over 5. So we get a 0 for this one. Okay. Grab a different color for my next one. As it approaches -1. And right away you might be thinking, oh, this whatever is in the bottom here, that's going to be a 0. We can't have that. You're right. So what we need to do is factor out the top to see if anything cancels. So this will factor to x plus 1, x minus 4, and oh, that's convenient. Those two cancel out for us. So really we're looking at plugging our -1 now in for that x on top. -1 minus 4 is -5. Okay, we can use this same factored out form for our limit as x approaches 2, and honestly as it approaches 4 too, but we maybe didn't see that right away that we would have to factor something out. And if we check that, plug that 4 in, 4 minus 4 is 0, okay, that's our limit. Okay, plug a 2 in, 2 minus 4, -2, and there you have those 3 answers. So let's look at another function. As x approaches 5, we just take this guy, plug it in, 7 over 1. So our limit's 7 as x approaches 5. Okay, that's basically like saying if we have this graph here, maybe a poor example, if we've got 5 out here and a 7 up here, this graph is somewhat coming towards this point right here. Like, who knows where it's coming from. But as it approaches 5, it is at 7 right there. So input, output, you could kind of think that too. All right, this one, limit as x approaches 0. Let's plug it in. You might see an error with that right away, and I hope you do see that error. We can't have a 0 on the bottom. So you might think, oh, no solution. Yeah, sorry, maybe not. Okay, we have to multiply the top and the bottom by the conjugate of the top, which is x plus 2, or sorry, the square root of x plus 2 plus the square root of 3. Do that here. Okay, so the top ends up being, we FOIL this, right? So we'll have x plus 2. So there's our first outside, inside, cancel. And then the last one is going to be -3. On the bottom, we end up with x times, and I'm just going to actually put this in parentheses because I think this will be fine for now. Okay, so looking at it this way now, we need to maybe simplify a little bit farther. And as you can see here, we simplify the top, and nothing is really going to cancel. I guess you could say this is just x minus 1. We end up with 0 over the same thing on the bottom. If I would have set this problem up correctly, sorry about this, you are going to have some on your homework like this that work out nicely for you. This one is not. I don't think that we're going to have a limit at this point. So you would just say, well, the limit does not exist. I don't think that we can simplify this any farther because we'd end up with still a 0 on the bottom. So this is a does not exist. Again, slightly rotten problem on my end here. Sorry about that, but you get the gist of these, I think. So let me know if you have any questions as you're working on your homework.